Welcome to part 2 of constructing a true table in Stanton form. In last lesson, we introduced compound statements and in symbolic form notations. So let's kind of recall what we did last time here. So in last time we said for condition for and or conjunction and disjunction, we say for the conjunction and is true if both components are true, and for the or is true if at least one of the component is true. So let's keep that in mind and construct when we construct the true table. So here, think about Stanton form first. In Stanton form, we say we set the table in terms of in rows, in terms of how many components. We have three components here: P, Q, R, and which is also given in this statement here. Note that I have P, Q, and R in here. So I have three components. So n is equal to 3. That means I need 2 equal to 3 rows, which is A rows. And that's why I have A rows over here. Okay, so that's how you set it up for A rows. Now, when we set up the rows, I'm going to put the component in the first box on the left, highlighted. So I have PQR. Well, how would I fill out the value for PQR here? So for the first component, we always make half true, half false. So we're saying the first 4 of them true, 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 true. The second 4 of them are false, 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 false. Next thing, the second component, Q, I'm going to do alternate 2 true followed by 2 false. So true, true, which is false, false, true, true, false, false. And the last component, I'm going to alternate true, false. So true, false, true, false, true, false, true, false. So this is the Stanton form here. Okay. Once I've done that, now I'm going to set up my true table. Before I set it up, let's look at my statement. Okay. So the statement here I have is P and Q is a first compound, followed by I also have negation of P or Q, and then I have a connective in the middle, right here. So tells me I'm going to first do the first component in highlighted part. So I'm going to do the first one here first, and then I'm going to do this one second, and then I look at the connective. So let me set it up first. So to set this one up, let's do it, set up the P and Q, the first component. So I have P and Q. Notice that I'm writing in from space in between them here. So this is the alternative method that we discussed in class, which is a pseudo version of true table. So I'm gonna put the grouping symbol in here. And the next thing is the connective or in the middle. I'm going to put in red. Next, I'm going to do the second major component. There's a compound statement here. It's negation of R or Q. Okay. Once I've done that, I'm going to think to myself, let me rewrite this one a little more better. Okay. So once I've done this, I'm going to work from inside out. Step 1, I'm going to look at each symbol components inside a parenthesis first. Once I finish the parenthesis, then I look at the connectives and or inside the parenthesis. Last, I will look at the connective that joining these two compound components together, which is the red or. So let's do the first one. The first one here, I'm going to do the P here. Notice this P is the same thing as this P over here. I just have to bring the value over. So I have P is true, 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 false, 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 false. And then the Q is the same as this Q over here. I'm going to bring the value over. So I have true, true, followed by false, false, true, true, false, false. Next, I'm looking at the connectives. So the connectives in this case here is my AND. So this is the AND connective. We say AND is true if both components are true. So let's look at the first row here. The first row, I have both components are true. Note that this is true, followed by this one is also true. So since both components are true, therefore the AND here must be true. Okay. And the second one I have true, true as well. The third one I have true, false. So it's false, 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 also false. I'm gonna label that one label the column so it's easy for discussion. So let's label this column 1, 2, 3 here by the order how we did it. So I'm gonna label this 1, 2. I'm gonna label this one 3. Once I finish the first parenthesis, I'm gonna look at the second parenthesis and look at the components inside the parenthesis. So the first one here have negation of Q. Again, for the negation of Q, I'm gonna have negate this. Negation of R. For negation of R, I look at the negation of the R here in this column. So in the first row, R is true, so negation of R must be false. Okay, and so I have the next second row is false, so it must be true. So follow in the same manner, I have false, true, false, true, false, true. Okay, that will be my column. I'm going to call this column 4. Now, once I finish that, I can look inside the same parenthesis again. There's one more simple component here, Q. So Q is just the second column over here, same over here. So I'm going to bring the value over. So I have true, true, false, false. So true, true, false, false, true, true, false, false. Okay, and I'm going to call that my column 5. Okay. Once I finish column 5, I can look at the connectives, the OR inside here, this OR. So to do this OR, I look at the true statement next to it. So notice that OR is the first component here is false, the second one is true. We say for OR statement to be true, we need one of the component to be true, or both components are true. So I have false, true, so therefore the true value must be true. I have true, true, so it's true. False, this is false. True, 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 false, true. And I'm going to make that my column 6. So 6, I'm at 6. Once I've done that, I'm going to focus, next one, I'm going to look at the last column. This column here gives me the true values of this whole statement. So, and to determine this OR here, the connectives here, I need to look at the compound components. This is the first statement of the OR. This is the second statement of the OR. So here, this one connecting these two components together. So compound statement together. So on the left part here, or components here, I'm going to use column 3. And then on the right, which is column 6, is going to give me the true value of the right component. So I am looking at this column, and this column gives me that one that I wanted. So look at this two column over here. I have first row, I have true, true. Again, always true if both components are true. So this is true. True, true. So this is true. I have false, false. So it's false. I have false followed by true, so it's true. So false followed by true, so it's true. False followed by true, so true. I have false followed by false, so it's false. I have false true, so it's true. And that is the last column. I'm going to label that my column 7. Okay. So column 7 is the final answer of the true value of the given statements. And we just complete our true table in the alternative form. Now, let's use this true table to answer question part B. Okay, part B, I have used the true table from part A to determine the value of this statement, given that P is true, Q is true, R is false. Explain your answer using the true table. Now first, let's locate the row that tells me P is true, Q true, R false, which is true, true, false. That is row 2 of the true table. Okay, since the true value in column 7 is true, this statement is true given P is true, Q is true, R is false. So let me draw a little arrow over here. I'm going to use that to answer my question. Okay. So since let's answer. So since P and Q here, P is true, Q is true, R is false, I could say the given statement is true. When P is true, Q is true, R is false, the given statement P and Q, or not R or Q, is true. And right now, C row 2 and column 7. Column 7. Okay. And this completes our discussion of truth tables. In the next video, we're going to make more truth tables involving conditional statements and biconditional statements. See you next time.